Okay, today we're going to be talking about section 6.6, which is composition of functions. And composition is basically whenever given two or more functions, you plug one function into the other function and evaluate. So basically, in place of x, you're putting an entire new function and you're going to calculate it out, okay? So there's two ways that it can be expressed. It can have f of g of x, where you have the parentheses, or you can have the little o, which is also exactly the same thing. G of f of x, g of f of x. They're the same exact thing. Now, this is what I need your brain to understand. If I plug a number in, I'm going to get a number out. If I plug an expression in, I'm going to get an expression out. So if I plug one number into another function, I'm going to calculate that out and get a number out. If I plug an expression in there, x plus 2 or x minus 2 or 5x plus 10, I'm going to get an expression out that has a variable in it as well. So let's go ahead and step right in this. Okay, we have f of x equals 2x minus 7, and g of x is defined to be 7 minus 13x. You are always going to work from the inside out. You are always going to work from the inside out. Super important that your brain understands that. So if you're working from the inside out, what this means is I'm going to take f at g at -3. I'm going to take my g function first because that's what's on the inside. So if I'm taking my g function first, I want to know and calculate what g at -3 is. Well, g is defined to be 7 minus 13x. So I'm going to write that down. In every place I see an x, I'm going to put the value -3. Okay? So then this is going to be 7 plus 39. 13 times 3 is 39, and 7 plus 39 is going to give you a 46. So what this means is if I see g at -3, that is equivalent to the number 46. If I see 46, that is equivalent to g at -3. So with that being said, I can put this number right where g at -3 is understood to be. So what I'm actually calculating, g at -3 is 46. I'm now going to be calculating f at 46. Okay, so if I'm calculating f at 46, what that means is I need to go ahead and I need to then calculate f at the value 46. Well, what is f defined to be? F is defined to be 2x minus 7. So every place I see an x, I'm going to plug in the number 46. So that's 2 times 46 minus 7. So 2 times 46 is going to be, and you can have your calculator out to go ahead and do that, but that is going to be a 92 minus 7. And I'm going to make sure that we have our calculator up so that you guys know how to do this as well. And then you're going to simply take 92 minus 7 to give you an 85. That means f at 46 is 85, which means this answer is 85, which means my final answer to this entire problem, f at g at -3 is 85. Okay? Let's do the next one. The next one, I have different notation. The notation I have now is g of f of 6. So what we're going to do is simply replace the little o with a parenthesis. Okay? And now we're going to work from the inside out. So if we're working from the inside out, I'm going to do f at 6. So I'm going to take my f function. My f function is defined to be 3x minus 5. And every place I see an x, I'm going to plug in the 6. So this is going to be 3 parentheses 6 minus 5. 3 times 6 is 18. Minus 5 is going to be 13. 13 is f at 6. So every place I see f at 6, I'm going to put now 13. So what this means is now I need my brain to focus on the number is touching the letter g, so I need to now pull the g function down. So the g function is x squared plus 8. Okay? So I'm going to replace x with 13. So this is going to be 13 squared plus 8. Okay? So I'm going to go ahead and show you this. 13 squared is... I'm going to put this over here, sorry. So I'm going to have 13 squared, and that gives you the 169 plus 8. You're going to go ahead and add the 8 to that, and you're going to get the 177. That is your answer, which means that is your final answer. So 177 is G of F at 6. Okay? So we've always worked from the inside out every time. Last example. This time I have 3 of them. So I have F at G at H at 2. And I have 3 unique functions, F, G, and H. So with that being said, I need to work from the inside out. So I'm going to take the H function, I'm going to do H at 2. Why? Because that is what is in the very middle of the function, from the very inside. So H is defined to be 2x minus 7. Every place I have an x, I'm going to plug in 2. So this is 2 times 2 minus 7. So that's 4 minus 7, which is negative 3. Okay? So now, every place I see H at 2, I'm going to put the value negative 3 in there, which means I'm now doing F at G at, what is H at 2? Negative 3. Okay? So I'm going to come over here, and I'm going to do the inside function. The inside function this time is going to be G at negative 3. So G at negative 3 is what I'm going to utilize. What is G defined to be? It's x squared minus 5. So that means every place I see an x, I'm going to plug in negative 3. Because it is negative, I need to put parentheses around that because I'm squaring not just the 3, but the negative with it. Minus a 5. Negative 3 squared is going to be 9. Minus 5 is going to be 4. What does 4 represent? It represents G at negative 3, which means every place I see G at negative 3, I can replace that with the number 4. So now I'm going to do F at 4. Okay, so we keep on going. So I'm going to take my F function. What is F defined to be? 2/3 times x. So I'm going to plug in a 4 for x to give me 2/3 times 4. Put that 4 over 1. Now you'll have 2 times 4, which is 8. 3 times 1, which is 3. This is F at 4. Well, what is F at 4? 8/3. Now, what I need your brain to understand is that this right here is the answer to F at G at H at 2. So 8/3 is the answer of F at G at H at 2. And 8/3 is what we're going to be having for our answer. Tonight's homework is 6-6 worksheet 1, composition of functions.